All right, this is going to be the video for Note 68, which is on domain, range, and zeros. So let's talk about domain and range. Domain are your possible x values of function. This is also known, when we talked about functions, these are the input values. So it's the values you put into the function. Range are your y values of the function. This is your, make the pen work, there we go, can't spell, output values. So once you put a value into the function, right, that's your x value, your input, what value you get out of the function, that is your y value, okay? Zeros. I know we've talked about zeros. We found some zeros. Zeros are the values of the function that make the function equal to 0. Super creative naming this one. All right. And then if you keep reading, I'm going to kind of pinch in here so I can get all of it. The zeros are the points where the graph of the function crosses the x-axis. These are also known as, of course, your x-intercepts. So when we use the term zeros, we're talking about x-intercepts. When we talk about x-intercepts, we are also talking about zeros. Okay, so domain, your x values, range values are your y's, and then your zeros are the values, the x values specifically, that make your function equal to 0. So problem number 1 here, I am giving you a set of ordered pairs, and I'm telling you outright this is a function, so we don't have to worry about that. I want to know 3 things. I want to know the domain values, I want to know the range values, and then I also want to know the zeros. Okay, so let's talk domain values. Domain values are the x values. So when we look at your function here, when we look at the x values, we've got 3, 9, -2, and 2. Now, technically, the order doesn't matter in how you write these. I'm going to go ahead and put them in numeric order. So -2, 2, 3, and 9. Little set notation there that's using the braces to hold the pieces together. Okay. Range then are your y values. So 5, 3, 0, and 0. Now, here's the fun part about this. When you have, when you have values that repeat, so in this problem, you have 0 and 0 for y. You don't need to write it twice. You just simply write it one time. So your range values would be 0, 3, and 5. Okay? And then the zeros are what x values, I'm going to go ahead and erase the little highlighting I did there. What x values make your function equal to 0? Well, here's a 0 and here's a 0. And those x values were -2 and 2. So the zeros of this function would be -2 and 2. All right, so we found the domain, we found the range, we found the zeros. Let's move on to number 2 here. And yes, all of those are the answers. That's all. All right, so problem number 2, we have another set of ordered pairs here. We've got some points, so let's talk domain. And you would want to make sure that you label your options here. And what I mean by that is I'm asking for 3 different things. So make sure I know what you are giving me in terms of answers. So just listing out values, yeah, you have to tell me, oh, these are the domain values. Oh, these are the range values. All right, so let's talk domain here. Domain, again, are your x values. So I have a 5, a 6, and an 8. They already are in numeric value, so I'm just going to write them down. 5, 6, 8. Again, the braces for set notation. And then if I look at range, we're talking about y values. So I've got a 10, a 12, and a 16. Again, in numeric order, so that's great. So 10, 12, 16, and zeros. So again, I'm going to go through really quickly and erase what I did for highlighting here, make it clearer. When I look at the zeros of the function, I'm looking for when is the function equal to 0? Well, I have a 10, that's not 0. I have 12, that's not 0. And I have 16, that's not 0. So the zeros here, I'd either put none or NA for not applicable, because based off of this function, you don't have any zeros, right? None of these points cross or are on the x-axis, so yeah, not helpful. All right, so that's what happens if we give you, or if I give you ordered pairs, right? You simply look at your x values for domain, your y values for range, and the zeros are I'm gonna go back to the first one, the ordered pairs where you have x intercepts, right? Those y values are 0, so the x values are the zeros of the function. All right, now let's say I don't give you ordered pairs, let's say I give you equations, and I want to find the domain for a function. So 2 things you're going to be looking for. Thing 1 is you cannot have any negatives under the square root. Okay, so if you have a square root in your problem, we're going to have to pay attention to that. And secondly, okay, speak English, you can't have any zeros in the denominator. A gentle reminder, if you have something like 5 divided by 0, remember that is undefined. Okay, mathematically. And so the problem comes in is we can't have that, right? We cannot have a 0 in the denominator because undefined isn't a point, right? You can't tell me, oh, it's 0, undefined. No, that's not a location, okay? So then the secondary part to this whole mess is we're going to be finding zeros, which we've been doing. So this should not come as a big shock or surprise. When finding zeros, set the function equal to 0 and solve, okay? So we're going to do 2 things for each of these questions. Problem number 1, it says to find the domain in the zeros. So let's start with domain. All right. So if I mark a little thing here that says domain, all right. So what are my concerns? Well, first concern was I need no negatives under the square root. There's no square roots in this problem. Okay, that's easy enough. The second thing was you can't have any zeros in the denominator. You don't have a fraction here. So the domain for this problem, and we've been talking about this when we've graphed your quadratic equations, domain for a quadratic like this is going to be negative infinity to infinity. It's everything, right? All possible values for x are completely acceptable. I realize I'm not a huge fan of where I put that, so I'm going to go ahead and put that off to the side. Okay, now for my zeros, because I do want to do 2 things here, right? It says find the domain, found the domain. And I want to find zeros. So let me make a little note here, right? Here's my zeros. Okay, so to find zeros, we're going to set the function equal to 0 and then solve for x. Well, we've been doing solving like this, right? We're going to go ahead and try and factor this quadratic. And let's see, multiplies to 8, 4 and 2, make the 4 negative, 2 positive. Quick double check here. Negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. Factors are working out great. Then to actually find the zeros, we're going to take each of our factors, set them equal to 0. Right? So we're going to have 2 little zeros here because we have 2 factors. So let's see. X is equal to 4 and x is equal to negative 2. So our zeros would be 4 and negative 2. So those are the answers for question number 1. We found the domain, which is everything. We found the zeros, which makes the values of x that make the function equal to 0, which would be 4 and negative 2. All right, sliding right along to problem number 2. All right, I want to find 2 things. I want to find my domain, and I also want to find my zeros. All right, so for domain, it said to look for, we can't have any negatives under the square root. There's no square root in the numerator. There is no square root in the denominator, so that is not a problem. However, the second part is you can't have any zeros in the denominator. So this is a fraction, clearly. We want to make sure that this denominator cannot equal 0. So I'm going to actually do something kind of weird. I am going to specifically set the denominator equal to 0. Right? I want to find out what the problem child is, and that would be if x is equal to 3. So if x is equal to 3, that denominator becomes 0, then we have that whole concept of, oh, it's undefined. That's a problem. So for your domain can be any number except for 3. There's a couple of different ways to write this. I'm going to go ahead and do interval notation, which is what we've been doing. All right, let me slide that back because I need a little space. So for my domain, I can have negative, whoops, that is not an infinity sign. There we go. Negative infinity up to 3, and then 3 to infinity. So, right, negative infinity to infinity, excluding the 3 in the middle. So using those parentheses here excludes the number 3 itself, but everything else is included. So that's my domain. Let's talk about the zeros. So to find our zeros, I'm going to take our function, right? I'm going to set it equal to 0. So x plus 2 over x minus 3, that's all equal to 0. I'm going to go ahead and multiply to get rid of this denominator. Don't like having that there. So x minus 3. And of course, you got to do it on the other side. X minus 3. That looks like a plus sign. Oops, that's not an eraser. Let's try that again. There's my eraser. All right, and so the x minus 3 on the right side, we'll take out the x minus 3, right? Those cancel out. And on the left side, here's the fun part. Multiplying x minus 3 times 0. Hey, folks, that's still 0. All right, so x plus 2. Subtracting 2 from both sides, we're going to get x equals. That's going to be negative 2. So if I take negative 2 and I put it into our function, we will get the value of 0 out. So our 0 is going to be, and actually, you know what? There's a couple ways to write this. I'm just going to go ahead and write it as x equals negative 2. I would take the set notation. I'll take this answer as well. So there we go. Domain is everything except for 3, and your zeros are x is equal to negative 2. And then the last problem here is going to be problem number 3. F of x is equal to square root of x plus 6. And as before, I'm talking about domain here. And I'm talking about zeros. So for the domain, right, the very first thing we talked about was you cannot have a negative underneath the radical. And clearly we have a radical here. So what we're going to do is we're going to take the expression, x plus 6, and we need to force it to be either 0 or a positive number. And the way you're going to force that is you're going to do greater than or equal to 0. So the greater than 0 is going to be all the positive numbers. Equal to 0, it's okay for this particular expression to be equal to 0. So if we solve this now, right, we're going to subtract 6, make that go. So x is greater than or equal to negative 6 is our domain. Now, if you need to visualize that, and that's okay if you do, right, on a number line here, we're at negative 6. And what we would have is then shading for everything that is greater than negative 6. And at negative 6 itself, we would use a bracket because of the equal to part. So for our domain then, we would exclude values that are less than negative 6. So we're going to start at negative 6 and go to positive infinity. And of course, negative 6 gets the bracket there. Okay, so there's our domain. And then for our zeros, we're going to take this expression, set it equal to 0. So 0 is equal to the square root of x plus 6. There we go. To solve this problem, right, everything in math has an inverse operation. So the inverse to a square root is going to be to square both sides. Okay. Give me back to my pen here. There we go. So on the left side, 0 squared is still 0. On the right side, we want to take the square and the square root and cancel each other out. So we've got x plus 6. Subtract 6 from both sides. And then x is going to equal negative 6. So at negative 6, that is where you have your x-intercept. And negative 6 is part of our domain, so that's okay. That's good. Give me 1 second to grab a highlighter here. There we go. I'll go orange this time. And that is how you find domain and zeros given an equation. So I'm pretty sure that was the last of the notes on this part. It is. There's all the bits, parts, and pieces for 1, 2, and 3 for finding domain and zeros given a function. All right, that's where I'm going to cut the video. As always, if you have questions or concerns, please let me know. And other than that, I will see you in the next one.